On the screen, we have this fourth-order polynomial, x plus 1, multiplied by x plus 2, multiplied by x plus 8, multiplied by x plus 9, equals 144. We need to find the solutions for this fourth-order equation, in other words, the values of x that satisfy it. We should expect 4 solutions for this problem. Notice something interesting here: if you add 2 and 8, and if you add 1 and 9, the sum in both cases is 10. That's a pattern of symmetry, and it's really the key idea behind problems like this. So anytime you see something like this, you can look at it and say, okay, this is 1 and 9. They add up to 10. This is 2 and 8. They also add up to 10. Now it's important to group the factors whose constants add up to 10 in separate brackets. In this case, x plus 2, multiplied by x plus 8, should be placed in one bracket, and x plus 1, multiplied by x plus 9, should be placed in the second bracket. You'll soon see why this step makes solving the problem much easier. Let's expand both sides and see what happens. Expanding this first bracket gives x squared plus 2x plus 8x plus 16 equals x squared plus 10x plus 16. Expanding the second bracket gives x squared plus x plus 9x plus 9 equals x squared plus 10x plus 9. Notice where the 10x appeared. That's the pattern showing up again. You see, this is the idea behind problems like this. We now have the same term, x squared plus 10x, appearing in both brackets. Let's call this term u. So now we have u plus 16, multiplied by u plus 9, equals 144. Let's move to the next slide and simplify. This is the equation we found earlier. If we expand it, we get u squared plus 25u plus 144 equals 144. We've now reduced a fourth-order polynomial to a second-order equation. That's the beauty of the symmetry pattern. Now we'll solve this second-order equation. Subtract 144 from both sides. The 144 would cancels out, leaving u squared plus 25u equals 0. We can factor u. U multiplied by u plus 25 equals 0. So either u equals 0 or u plus 25 equals 0, which mean that u has to equal negative 25. Please recall that u equals x squared plus 10x. Let's look at the first case, u equals 0. Remember from the previous slide, u equals x squared plus 10x. Substituting u equals 0, we get x squared plus 10x equals 0. Factoring x, we get x multiplied by x plus 10 equals 0. So the solutions are x equals 0 or x equals minus 10. Now for the second case, u equals minus 25. Substitute again, u equals minus 25 gives x squared plus 10x equals minus 25. Add 25 to both sides to get x squared plus 10x plus 25 equals 0. This can be written as x plus 5 multiplied by x plus 5 equals 0, because the constants 5 and 5 add up to 10, and their product is 25. So here, the solution is x equals minus 5, and because it comes from a squared term, x equals minus 5 is a repeated, or double, solution. Therefore, for this equation, x plus 1, multiplied by x plus 2, multiplied by x plus 8, multiplied by x plus 9, equals 144. We have 3 real solutions: x equals minus 10, x equals minus 5, and x equals 0, where x equals minus 5 is repeated, double roots. This symmetry-based approach transformed a fourth-order problem into a simple quadratic. That's the power of elegant algebra. If you enjoyed this explanation, subscribe to this channel and visit mathlive.com and stay tuned for more elegant math solutions, step-by-step reasoning, and visually clear explanations.